A gas cylinder is fitted with a safety valve which releases gas when the pressure inside the cylinder reaches 2.0 times 10 to the power of 6 Pascal. Given that the maximum mass of this gas the cylinder can hold at 10 degrees C is 15 kg, what would be the maximum mass at 30 degrees C? This diagram shows a gas cylinder with a safety valve. When the pressure of the gas in the cylinder reach the maximum value at 2.0 times 10 to the power of 6 Pascal, this valve will be opened and some of the molecule of the gas will be released. After the gas part of the gas released, then the pressure of the gas will be adjusted and reduced. So the maximum value that we can get in this cylinder is 2.0 times 10 to the power of 6 Pascal. Once it exceeds this value, the valve would automatically opens and the pressure will be adjusted. According to the information given by the questions, we need to consider two different states of the system or the gas cylinder. In these first initial states, the temperature of the gas is 10 degrees C. The pressure is 2.0 times 10 to the power 6 Pascal. That means it is at the maximum pressure. And the M1 is 15 kg. So that means when the gas reach this maximum values of the pressure, the mass inside the gas cylinders is the 15 kg, the mass of the gas. Now, if we heat the gas to the new temperature, which is T2 equal to 30 degrees C, then of course, the pressures of the gas would exceed this maximum value, okay, 2.0 times 10 to the power 6 Pascal. But according to the mechanisms of this valve will automatically opens and allow some of the gas to release. As a result of the gas release, then the pressures of the gas will be adjusted back to the same value, which is 2.0 times 10 to the power 6 Pascal, which is a maximum pressure that this cylinder can hold at 30 degrees C. At 30 degrees C and 10 degrees C, the maximum value this cylinder can hold for the maximum pressure would be the same. But the mass of the gas in the cylinder would be different. If it is at 10 degrees C, the M1 is 15 kg. But if it is when it is T2 equal to 30 degrees C, what is the M2? This is a This is a quantity that we want to find. But we can note that because at this T2, 30 degrees C, the molecules in the gas molecule in the cylinders move faster, it can produce a higher pressure. So that means if we set this P1 and P2 same at the maximum value, we can expect that the mass M2 in the cylinders at T2 equal to 30 degrees C must be less than the mass of the gas when the system is at T1 equal to 10 degrees C. Now we can start to find out what is the maximum mass of the gas in the cylinders at 30 degrees C and the maximum pressure and the pressure is at the maximum value at 2.0 times 10 to the power 6 Pascal. We firstly write down the ideal gas equations, PV equal to nRT. So that means we assume the gas is the ideal gas. Now, since we want to find what is the maximum mass, so it is better we change this n into the m over m, where the small m is the mass of the gas and the capital M is the molar mass of the gas. Now we can write down the two equations for the two different states mentioned in the questions. For the first state, it is the P1V1 equal to M1 over M times RT1 based on these equations that we have, and we name this equation as 1. And for the second state or the final state, which is at 30 degrees C, we have P2V2 equal to M2 over M times RT2. We name this as second equations. Now, since this gas that we consider in the cylinder is the same. So the capital M is the same. The symbols for the molar mass is the same. And the mass, since the mass would change before and after for the different states, then M1 and M2 are different. R and R same, temperature also different. V1 and V2 would be the same. And P1 and P2, since we are considering the moments when the gas pressure achieve the maximum value, this maximum value 2.0 times 10 to the power 6 Pascal. So we can also say that P1 and P2 same. Therefore, now we can set equation 1 same as equation 2, because left hand side the product of P1 V1 same as a P2 V2, and at the right hand side then these two terms at the right hand side of the equality sign must be the same. That's why 1 equal to equation 1 same as the equations 2. We cancel the capital M for the molar mass of the gas. The gas constant R also cancel out, so that means we have from the equation 1 M1 T1, and from the equation 2 we have M2 times T2. So these two terms are equal. M1 T1 same equal to M2 T2. We want to find the M2, which is the maximum mass of the gas in the cylinder at 30 degrees C, when the pressure is at the maximum value 2.0 times 10 to the power 6 Pascal. Therefore, we write this M2 as a subject of the equations. So we have M2 equal to T1 over T2 times the M1. Now we can substitute value for T1, T2, and M1, where the T1 is the initial temperatures, which is 10 degrees C, but we must substitute in the Kelvin, so it is 10 times 2 and 3.15 Kelvin. And for the final temperature T2, it is 30 degrees C, so in the Kelvin it is 30 plus 2 and 3.15, and multiply with M1, which is the maximum mass at the initial state, which is 15 kg. It happens at 10 degrees C. We finally get M2 equal to 14 kg, which is less than the 15 kg of the maximum mass when the temperature is 10 degrees C. 10 degrees C, 15 kg, 30 degrees C, 14 kg. So this is consistent with the results that we analyzed before this. Because at 30 degrees C, the molecules in the cylinders move faster, so it can produce higher pressure in the cylinder. So since now we consider two instances or two states where the pressure is the maximum value, which is the same 2.0 times 10 to the power 6 Pascal, but at the different temperature. So that means at the higher temperature where the gas can move faster, the number of molecules should be less in order to get the same pressure in the cylinder.